Good morning, all of you. Today we teach about data representation into memory. Data representation into computer memory. We are familiar with decimal number system for our routine business. The decimal number system is a position number system. We use the symbols called digits in the decimal number system, which are 0 to 9. Further, we use alphabets in language such as A to Z. Besides numbers, alphabets, and mixture of both of these are called alphanumeric. Computer began an electronic device is not compatible with these entities. Device. It operates on electricity which has only two states and off. The binary system is such a B-state number system that can represent the two state called on and off an efficiency way. It means, for example, number 916 is alternatively presented as 900 plus 10 plus 6. We use 10 symbols called digits in the decimal number system, which are 0 to 9. Special characters such as punctuation marks, operators greater than, less than, plus, minus, etc. And currency symbols, dollars, rupee symbol, etc. are used. All these digits, the main way how we communicate using languages. Besides this, we have sign language, braille language, body language, and facial expression for able people, differently able people. It requires a special B-state language having only two symbols, one to represent off and another to represent on. The binary number system is such a B-state number system that can represent the two-state call on and off in efficient way following sections. Binary number system. The binary number system has two symbols, 0 and 1 single binary digits is called a bit. A valid binary example is 101. A decimal number is converted into its equal binary by successively dividing it by the base 2. Since the binary number system uses only two symbols, 102 is not a correct binary number. However, it is correct decimal number. To quickly identify the given number is binary number. A decimal number is converted into its equivalent binary by successively dividing it by the base 2. An alternative method is to first subtract the largest possible power of 2 and keep subtracting the next largest possible power from the remainder, marking ones in each column where this is possible and zeros where it is not. Unsigned integer number representation. Any unsigned integer number can be represented into the computer by converting the number into equivalent binary number. Sign integer representation. To represent 0, positive, and negative integers, three different representation schemes are used. These methods are: first, sign sign magnitude method; second, first complement method; and third, seconds complement method. Arithmetic operations such as addition, subtraction, etc. can be done on such numbers. Here, such simple representation cannot store negative numbers. To store positive as well as negative integer numbers in a computer memory, to complement method is used. Floating point number representation. To present fractional number, floating point number representation is used. The IEEE to 32-bit single precision method is commonly used to represent a real number. Here, IEEE represents Institute of Electrical and Electronics Engineers, which is the world's largest professional association dedicated to advancing technological innovation and excellence for the benefit of humanity. Character representation. In computer memory, characters are represented using bit patterns. Group of 7, 8, 16, or 32 bits can be used to represent each character. The rules that determine such bit patterns in a special specific length are known as coding schemes. Historically, 7-bit American Standard Code for Information uh, in Interchange Code, 8-bit American National Standard Institute ANSI code, and extended binary coded decimal interchange were used. These coding schemes represent character into 7 or 8-bit binary code. We may represent limited number of characters. Further, these character schemes do not represent all the characters in all language in uniform format. Presently, Unicode scheme is used to present characters into the computer memory. Unicode provides universal and efficient character presentation and hence evolved as modern character representation schemes. Unicode scheme is developed and maintained by a non-profit organization called Unicode Consortium. Unicode is also com- compatible with other coding schemes like ASCII. Unicode use either 16 or 32 bits to represent a character. Unicode has capability to represent characters from all the major languages across the world. The added characters were from Chinese, Japanese, and Korean language and culture. Presently, the Unicode latest standard 32 bits can present more than 1 lakh character in unique pattern. Image representation into computer memory. Image represented in a computer memory is called digital image. The reason behind this is that the image is ultimately converted into sequence of zeros and ones for its possible representation into the computer memory. Another way to present an image into computer memory is dividing the image into fixed number of rows and columns. Each cell is known as pixels. One way to describe an image using digits is to describe its contents using position and size of geometric forms and shapes such as lines, curves, rectangles, and circles. Such representation is called vector image representation. A vector image can be easily enlarged or shrunk without efficient, uh, effici- uh, efficienting the quality of the image. Another way to represent an image into computer memory is dividing the image into fixed number of rows and columns. Each cell is known as pixel. Each pixel represents a value that represents the given color at any specific point. If you divide the image using more number of rows and columns, very fine information about the image can be stored and hence quality of the image increases. The set of pixels normally in the form of two-dimensional array is stored in computer memory as a raster image or raster map.